towards the left. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum everyone. This is chapter number 1 about how science work. We know very well. Making the measurements, we already discussed about that topic before. So here it's just tell you a condition in which you're going to measure the volume of gas in the syringe. When you're going to react these two things, which are these two, dear students? You know very well. Welcome, Muhammad. You know very well here we have these two things. Number one, hydrochloric acid. What is this? This is HCl. Okay, and that is marble chips. When both react with one another, here a gas is produced. When this gas is produced, it's moved into that syringe, and whatever the volume is covered in the syringe is calculated, or you can say that we measure. So that is the measuring of the volume of the gas in the syringe. Here I assign you an assignment. If the temperature gets higher, how will this affect your volume reading? It was a question, very easy and simple. So you should know that when the temperature mostly in a is high, mostly the rate of reaction increased, mostly, but not every time. When you're going to increase the temperature, what happened? Mostly the rate of reaction increased. This happened mostly, but not every time. Keep it in your mind. Okay, you should consider the accuracy of your measuring instrument. And second thing, you also care about your instruments. What the instrument you are going to use. That should be very important for you. Is it accurate? Its accuracy is correct. For example, the readings that mentioned here, that should be correct. Maybe there is any error or there is any problem, so you didn't get correct or accurate results or correct data. After that, we are going to discuss about the accuracy. What is an accuracy? So the definition of accuracy is mentioned here. For this, we also discuss another experiment, another example. Accuracy tells us how near the true reading your instrument is. That is actually your accuracy. Okay. Example, let's see this example in detail. An expensive pH meter. If you have two types of pH meter, but it tells you here first about expensive one, or you can say that the good one will probably give reading near the true value than a cheaper model. If you have two types of your instruments, pH meter, one is expensive and second is cheaper, you know very well which gives you good results. It's same like this. If someone have any car, like I'm going to give you the example of the car like Toyota or Hyundai or any other, but a second who have Ferrari. So you know that which one is more good and more effective and which can move more fastly. So in the same way, the cheaper things mostly not going to give you good result compared to the expensive one. The reading would also depend on you. It's not only a thing, an unknown person who even can't ride a bike and you give him the keys of Ferrari, he can't drive Ferrari well. Even Ferrari, you know that it can move very fastly, but the things you should also know that the experienced one who know that how to drive it. The manufacturer, instruments, instructions on using and storing the pH probes. This is the pH meter, and here is its prop. How you going to use this one and how you get the reading. What it tells you, it's simply going to tell you, you should know how to use the instrument. If the pH of a solution is tested in different labs by different people and they all get similar results, we call the pH okay. What it means, that should be 100% accurate, correct reading, because we use an expensive pH meter, we use a person who follow all the instructions, and then you can go anywhere with the same solution, it gives you same result. The more expensive pH meter is also likely to have better resolution. It's very easy to understand about the resolution. If you have a mobile and its camera, you can say that 4 megapixel. When you're going to compare the picture with 8 megapixel or 16 megapixel or 32, you should know that as the megapixel is going to increase, the picture will be more good. Its resolution power will be more nice. It will respond to smaller changes in pH. This may not matter in some experiments, but it could be significant, for example, in enzymes investigations. For enzymes, we use these kinds of things that will help a lot. So till here, my dear students, if you have any question, please raise your hand, otherwise type no. Hurry up. Thank you very much. That's great. Excellent. Now, after that, we move towards the precision of a measuring instrument is also important. Instrument will have small scale divisions. For example, it's a scale, okay, from here to here, it's, for example, 0 to 10. That's the between point. We say that this is 5. Then we're going to make half of the 5, 2.5. You also going to half this one, then that is equal to 1.25. So that is the small division that you're going on. Understand? So it will give the same reading again and again under exactly the same condition. That is very important statement. You're never going to change the condition. Okay. As we done here, if I move you a little bit up here, you can see that the divisions of the condition here, if you're going to change the temperature, it means you're going to change the condition, then your result will be changed. But if you are not going to change any condition, your result should be same, accurate, no change. But precision and accuracy are not the same things. So this example, you can easily understand. A student weighs exactly 2.51 gram of iron on 2 different balances. He repeats this 4 times on each balance. So every time you can see that balance A gives a passive set of repeat readings. The readings are grouped closely together. 1 time, 2 times, 3 times. You can see here, but they are not accurate. Near, but not accurate. But when you see here, balance B produce an accurate value, the average of 4 reading is 2.51. Here you get the average, mean to say you add all of them, then divide it to the total value, but the set of the reading are not precise. This reading are spread out. Okay. Now after this, we can see here and learn about error. What is an error? It's very easy to understand. Error, you can say that any mistake or something wrong. Then we also have Human error. Sometimes the instrument is accurate, it's work properly, it's expensive, but the person who going to perform, or a scientist who going to perform a practical, or he going to do any experiment, he don't know how to properly use the instrument, and maybe sometime he not carefully performing his experiment, then the error is due to that scientist or that person. So we called it as human error. Okay, you can see here two cartoonists. So they are going to perform a reading. For example, I gave him A, and this diagram I label as B. Here, this one, you can see how carefully she looked to the, but in the second A1, she is little bit not much carefully observing the burette. So what will be the end result? Will come here now. Let's see here the reading that mentioned under this. So carefully listen that, my dear. In the first cartoon, the student is just careless. You can see here. If he or she repeat his experiment, the result could be spread randomly. Result will be not same all over the place. This is called random error. So what is a random error? When you're going to repeat your experiment every time, it's give you different reading. Even practical is same, instrument is same, condition is same, but due to this person or this lady or this cartoon, it's because she is careless and not going to bother how to measure the correct or accurate reading. In the second cartoon, his partner is more careful. Look how she near to the burette, and his level of eyes just same as the level of meniscus. His partner is more careful, however, she is not reading the volume in the burette correctly. Even she is not going to measure correctly the volume. You should read to the bottom of the meniscus curved in the surface of the solution. It's very easy to understand. I just going to draw for you. For example, that is a burette. Okay. When you're going to add any liquid in the burette, you will get two types of layer like this. When you fill the liquid in the burette, you will get two layers. One is upper one, second is down one. That is lower meniscus and that is upper meniscus. If she don't know for which solution we need to read which layer, upper or down one, then she just going to do the mistake. For colored liquid, we have to read other one, and for colorless, we need to read the other meniscus. So her repeat reading will be consistently incorrect. Even she is going to do, but this error is named as systematic error. That is your last part, from where we just understand about systematic error. Now your assignment, so please everyone should do or write these two questions about the assignment. Will all her reading be too high or too low? That is question number 1. And second question, why would not it match in this case? These are two your assignment questions that you need to solve with yourself. After error, we have to move next.
Mr.
Yes, my dear.
We're writing the copybook. Yeah.
Yeah, no need, or even you just send me on my WhatsApp, okay? Now, after this, you should design the investigation and you can perform. Inshallah, when we will be in the lab, we will perform this experiment again, choosing the value of variable, how your variable is going to change, and the range of your experiment. Now, different types of variable. There are different types of variable. Let's see one by one all of them. Number one, categoric variable. These are variables that can describe using words. Are types of acids, hydrochloric acids, or type of carbonates, calcium carbonates. Ordered variable. These are types of categoric variable that we can put into an order. For example, surface area of calcium carbonate, if large lumps, medium lumps, small lumps, as a way of describing the value of variable. Then continuous, these are variables that we can describing by any number. Okay, variable means changings. The value are going to change. Our measurements, for example, 17.5 centimeter cube. Then it will change after that. After this, we move toward the next one. Discrete variables. What are these? These are variables that can only have whole number values. In mathematics, you know very well about the whole numbers. So, not so fair test. If you perform a test and in some investigation, it is easy to change one variable at a time and keep all the other constant to make a fair test. But however, in other investigation, controlling all the variables that matter in different or even impossible. An example is an investigation into the effect of fertilizers or plant growth. So that is very important for you to know about when you're going to add fertilizer in a field for the plants. If you add more fertilizer, that may be harmful of a plant. But if condition is different, it is not too hot, maybe the small amount can be damage your plant more. So that is also depending upon the conditions. Now, this is the last part of the lesson where after observing, after performing the experiment, after getting the reading, writing that reading, and then collecting the data, now this time is to present your data. How you going to present whatever you investigate, whatever you collect? There are different types. You can present your data in the table form. You can write a table like this, that is in dependent variables, temperature. For independent and dependent variables are time. So you know that time is moving constantly. It will never going to change, but temperature you can change. Okay. So here you also see the first test, second test, third test, and the mean value. Whatever the result you get, divided all of them after addition on 3, you can get the mean or average value. My dear students, till here, if you have any question, please raise your hand. Otherwise, type no. Hurry up. Quickly. That's great. Thank you. Well done, my dear. Very nice. But about the others, everyone should please participate well. Okay. When you get or collect the data, then what you need, you also can draw a graph. You know very well that is your x-axis or that is your y-axis. Even you can change them. So whatever the data you collected from your results, you can make a graph. Or graph in mathematics, you already learned there are different types of graph: line graph, bar graph. You can see here charts or in a circular form of graph, you can draw about this. So that is all about first lesson, in which a scientist perform experiment depending upon the instruments, his professional experience, then the working of in the lab, how accurately he going to use and choose the instrument, and about the conditions. So then it will be able to get a fair test and a accurate report or data. Now it's time for your homework. Everyone, please open your textbook, page number 16. Textbook, page number 16. Here you need to complete these fill in the blanks on question number 1. Copy and complete. Everyone should write the correct answer in these blanks. That is your homework. From page number 16, A, B, C, D, E, F, G, H. This is your homework and you need to complete this all on your textbook. No need to write on your copybook. No need to do anything else. Only one question you need to solve. Now, anyone want to ask anything, please, he can raise his hand, otherwise type no. Well done. Very nice, excellent, my dear. Thanks. That's great. Very well. Okay, no problem.